bulk indexing part. I never taught you on the bulk indexing part last time, right? But I just showed you the difference in speed, right? Did I show you difference in speed, like doing the sequential one and the bulk index one? Did I show that, Matthew?
No.
Okay, great. Then I should show you the first. That will be my first part. Once done, is it clear for you, or is it very small still?
It's a little small, so if you can zoom it little more, then it will be clear.
Okay, maybe I just pull out for. How is now?
Yeah, it's better now.
Okay. So the fundamental difference what we are going to see today is to do the what is the difference between the sequential indexing and bulk indexing. So if someone says something called sequential and something called a bulk or a batch update, so what is the difference you think between both will be there? So what comes to your mind? Someone says a sequential and a batch.
So sequential, if it goes for the SQL thing, one by one it will update. Let's say we have a 10 update statement. It will update the first one and then it will commit. It will go for the second and then it will commit. And if it is a batch one, it will take a group and it will commit at one time. I mean, after completing everything, it will commit at once.
Yeah, perfect. So as you are a database, as you have experience in database, what do you think is a right for a database? A sequential or a batch? What do you prefer generally?
It depends on the situation. If we have a huge amount of thing, we'll go for batch because in between, if some error happened, it will not commit the entire thing.
Okay. So if you have like huge number of things, you said you will go for bulk or a sequential.
Bulk one.
Okay. And when you choose the sequential one, what is the constraint you will choose sequential?
Sequential, I'll choose if we have very less amount of data which is stored inside the DB table.
Okay, fair enough. So, like being a DBA, you know the number of connection pool a database can have, right? So, if you just
Right,
open and see a database, the active connection, what the database or system can have, it actually varies in a great extent. That's
right,
a different story altogether, right? In my case of
right,
MySQL, the default connection would be like 8 or 10, if I'm not wrong, something of that sort. Maybe for other data, active connection. I'm not speaking about the concurrent parallel connection. I'm just speaking about the active connections are allowed in the system. So as we know that the only 8 connections are allowed by default in nature. If we want to have a better connection rate in MySQL, then definitely we have to increase the size in the config file. Then we will proceed further, right? That's why we
correct,
operate in that because as we know that each connection creates a thread. Which actually creates like a lot of resource or a lot of content in the system because if you we can't say that I can parallelly increase my connection request to 100 or 1000. It definitely has an impact on the database system. Similarly, like the main part why they try to yeah, have a control limit on the connection part is what is Elasticsearch, the difference between the search engine and database, and what is the point you would pick up the search engine or database, and what is a constraint that you would choose this kind of technology stack. When should you choose and when you should not choose the technology stack? Then we understand the various terminologies are the jargons what people are using in Elasticsearch. Then the installation of Elasticsearch, how to install standalone in our computer. I will help you with the instruction part. Then we will go and understand the architecture of the system, how the system is being built on the whole of the top. We will be having a complete understanding of the big picture. That's the whole idea of today's class.
Okay.
Victoria, do you have any laptop? You have a laptop with you, right?
Yes.
So can you let me know what is the spec of your laptop? Then let's start then. So what is Elasticsearch on the first hand? So if you see from the 5 bullet points, what I mentioned in this slide is like you will see the different features what Elasticsearch offers to its users. Like they have some fancy word called real-time distributed search and built top on Lucene RESTful API open source and document base, we will try to understand point by point, and then we will take up from that point. We will try to go from that point. So you have some word called real-time distributed and analytics engine. So that's where we have to understand what is something called real-time systems. If you are from computer science major or if you are working in a company, there are like two kind of systems generally available in the market: real-time and non-real-time systems. The real-time systems are systems where they attach the sensors. Like if you have any temperature sensors attached to a machine, that machine has to record the data continuously from that sensor and have to send a feedback to the user. So all the data being collected from the system, it's real time and will be processed in a real time. That's what the people calls the real time system. And the traditional non-critical real time system or system where the criticality is not very important. The criticality remains a very huge impact in case of medical instruments. If you are trying to measure the blood pressure or some critical like ECG, it should be real time. If it comes like 10 minutes delay or 15 minutes delay, it doesn't make any sense for us. It should be a real time, because whenever we record any medical instrument, it has to we have to get the value in real time, at least by not less than zero point 0.5 seconds. That's what the real-time system really meant is. And what is they are trying to mean here, something called real-time distributed is, let's say you have a system wherein which you can divide your work among multiple machine. From that multiple machine, as you divide a work across all the multiple machine, you get the work from all different machine, then you process that and you then display to the user. That's where you have something called real-time distributed search. That's what they are trying to mean here. Let's say like, maybe let's take an example of a distribution. Let's say government is distributing the maybe a ration card, or maybe a voter ID, maybe ID for some kind of a purpose. If there is only one signal person who's distributing the work or distributing among the people, he may take X amount of time to give the ID to n different user. What if government employs like multiple persons to do the job? Definitely there's a reduce in timing, right? So each can take like a set of IDs with them, then they can go sector by sector, then they can distribute to the people across living in that area. So my work to time to complete my works reduced by half. Do you agree with me till that point, Victoria?
Yes.
Okay. Now, if you directly translate the same logic to computer, I have like n number of computers with me. What if I can distribute my workload or my efficiency, not by the efficiency, or my workload or the power to drive the system across n number of people? Then certainly it doesn't take n time to get processed. So if I have more resource in my system, definitely my response time is better. Here the response time, what I'm trying to say here is my search experience or the time to get the document. It improves significantly. That's the key factor here. Like these concepts actually come from the world called something called scalability. There are like two kind of scalability the systems are. One is the horizontal and one is the vertical. Let me just pull out some picture for the horizontal and the vertical part. Can you see this picture?
Yes, I can.
So if you see, like I was discussing on the scalability part, right? Traditionally, computer science people or the computer science architect or in any enterprise, they do scale to increase the workload by two means. One is the vertical and one is the horizontal part. The vertical part is like sorry.
No, continue.
Yeah, sure. So the vertical part is, let's say you have a laptop with you. Currently, you have a CPU of you have a CPU of i3. Let's say if you want to upgrade to i5 or i7, definitely you can do that. Still, you can increase your RAM from 4 GB to 8 GB or even 16 GB. And similarly, your hard disk space also can be increased from 1 TB to 2 TB if you have a sufficient amount of a hardware resource. But if I say that, can you keep on increasing your laptop specification? That is not possible. The reason is the hardware constraint. The board or the motherboard can handle this much of CPU, or it can handle only, it can have only a certain constraint on the improving or upgradation part. But this is on the vertical scalability. Earlier people were used to do the vertical scalability. If they want a higher performance, they increase your the CPU cores, or they try to increase your CPU RAM. That's why they tried to doing earlier. But what happens from the year of 2000 or 2010, the concept of NoSQL came in. The NoSQL mean here is not only SQL. By beating the traditional system, then now their design is, I have like multiple machines in my office or the server. I will install individual pieces, or I'll distribute my workload across all this machine. Then I retrieve back my search result. This analogy, like that's what we discussed some time back. In case of government wants to distribute a ID to the people, instead of one person doing that, I am allocating 10 resources or 10 persons to do the job, so I can get my work in much more faster way. That's what the key idea here lies in. So now you understood, right, what is a vertical scalability and what is a horizontal scalability. Hello.
Hello, can you please take that again?
Sorry,
Can you take the difference again, horizontal and vertical scaling?
I'm not able to hear your voice clearly, Victoria. Can you be a bit louder, or something mic problem is there?
Hello, I said, can you please take the difference again between the two?
Sure, sure, sure. The vertical scalability is you keep on adding your hardware capability to the same machine. Let's say you have a laptop with you. In that given laptop, if you start upgrading your RAM or a CPU, if you want to upgrade from i3 to i5, or if you keep on adding to a resource to one particular machine, that is called as a vertical scalability. If in the same case, if I have like multiple machines or a multiple laptop or a desktop, I spread my work across these machines, and then if I get data from that machine back, that is called as a horizontal scalability. Are you with me now?
Okay, yes,
Are you clear?
I do now. And I can see the picture, yes.
Yeah, great. So this is the another example. Can you see here? See, in this case, the vertical scalability, one CPU, 1 GB RAM is like they say $10 per month. They say 2 GB $20 and 4 GB is $80 per month, which is the cloud environment. Similarly, in the horizontal scalability, they are using the same machine. So if they are trying to use like 4 CPU machine. Now see, with the help of 4 CPU machine itself, they are trying to bridge the same effect. Can you see here? That's where the horizontal scalability comes to the play. Now you got right?
Okay.
Great. So then there is a something concept called something called analytics engine here. The analytics engine is like you can do like lot of data analytics operations on the data using Elasticsearch. You can try to get like what is the count, and what is the number of document being processed, or what is the maximum number of transaction, what is the highest fare. So you can query the system to get whatever insights you are looking for. So the querying, with the help of a querying part, you can interact with the system and get the data back. That's where the Elasticsearch. Then you have something called Apache Lucene. It's built on Apache Lucene. Apache Lucene is basically a library. On top of that library, Elasticsearch people wrote a wrapper, or a kind of a small abstraction wrapper. From that, they try to develop or made some advanced feature on top of Apache Lucene. Then they got data from that. Then they could develop the system. That's where the Apache Lucene comes here. And it says that it scales easily as it supports like a horizontal scalability. So I can divide my work into multiple machines, and the access to the machine comes from the forms using the RESTful API. What I meant by RESTful API is Let's say I develop a application programming language called X, or even call it as a Java. If I develop something in Java, only a similar application in Java can interact with the system. Other application, if you ask them to interact, they have to follow a different strategy. Let's say Python program, if you wants to interact with the Java, it's not possible directly because Python works in a different way and Java works in different way. So, but what Elasticsearch people have designed is they created a platform wherein which all the interfacing happens through the REST API. REST API is a technology or a kind of a concept wherein which the system interacts through the backend using the HTTP protocol, hypertext transfer protocol. Through that, we are able to interact with the system. So the REST API interface is common for many programming languages in the world. Even it starts from C, C++ to advanced language like a Java and Python. So all programming language can seamlessly interact with the REST API protocol so that this system becomes language agnostic, which is like any system available in the market. You can call it Python, Java, C++, C Sharp. Any system can interact directly with Elasticsearch without much effort. That's the key idea here. And the fourth point, what we are discussing is it's completely open source. What I mean by open source is you can go to github.com, then you can get the complete source code of how Elasticsearch is completely built. From that, we can understand that how the system is built and you can modify your source code according to your wish. So if you are modifying your source code, similarly, you have to also publish in the open source platform. That's what the license actually speaks here. So you can completely customize the Elasticsearch in case if you want to need, but you have to have like a professional development team to do the job. That's where it starts here, and it's all goes to something comes under family of document based. Have you heard about NoSQL, Victoria? Any chance before? NoSQL. Hello, Victoria. Can you hear me?
Yes, I can hear you.
Have you any chance? Have you heard of something called NoSQL database?
I've heard of, yes, SQL and NoSQL data.
Yeah, great. So if you heard about the SQL database in the market, you have mentioned about the MySQL and MariaDB or a MS SQL, Microsoft's database server. If you go to the NoSQL family, you have like a four different kind of database, which is the column family, the graph, document based, and a key value pair. Okay, these are the four different families. What is there available in the market in the current day? So the database family, what we are discussing belongs to Elasticsearch belongs to something called document based. That's the idea what I want to enforce here. Do you have any questions or doubt at this point, Victoria?
Hello, what did you say?
Do you have any questions
Hello?
or doubt?
Yes, the thing is, are we doing a recording of this session?
This session is recorded. You can contact Mind
It's
Magics to
recorded.
get the recorded session.
Okay, so I can get the recording. Okay, okay, because I'll probably need to like listen to it again to really digest all that you are saying.
Okay. If you find my accent is very hard, please let me know. Okay.
Okay, okay, I'll let you know. Chimama.
Sure.
What happens when you knock it off?
So now let's understand who are the people actually using Elasticsearch. Almost all famous websites in the world like Stack Overflow, Facebook, Wikipedia, Mozilla, Netflix, all major companies around the world are using Elasticsearch to power their search operation or to facilitate the searching operation in this system. So almost all major companies are using around the world. Victoria,
Okay,
have you
can you
used
please
Stack?
okay,
Sorry?
can you please give me an example of what, like, maybe let's use, is Amazon there? No. Like what, how Netflix uses Elasticsearch? Can you please explain?
Sure, definitely. I'm glad to explain that. If you have used Netflix before, you might have searched for the movie name, right?
Yes.
Do you provide complete movie name when you give a search, or you give a partial movie name?
Sometimes I give partial movie names or like partial the one of the lead actor or something name.
Yeah, yeah. What you answered actually as a question. So most of the time, or the most of the user does not know the complete name of the movie. That's the most reality. Most of the only the famous movie. If we have something in our mind, we have we will give a complete movie name. In general, most of the time, we might search with the director name or the lead actor, or we search by the partial movie name which comes to our mind. In case if you are giving a partial search, how do you think in the back end Netflix is able to power or able to retrieve the movie list from their catalog? The movie searching catalog itself is being powered by Elasticsearch. So whenever you search something called Jurassic Park, the Jurassic Park itself contains like several parts, part 1, part 2 and part 3. So on searching something called Jurassic Park, if you are able to get all the three parts, then we are actually more successful, right? If the user wants to have like a more final control, let's say he just says Jurassic Park 1, then his result is being sorted to the top. Now the Jurassic Park 1, the result will be displayed on the top, and the 2 would be displayed at the second, and 3 would be displayed at the third. Do you agree with me? Hello?
Uh, Yes, I do.
Yeah. So have you ever wondered how those kind of search operations is able to perform, or how is performed? Everything is performed using Elasticsearch. Or if you might use the Google search engine, if I search for a thing called Africa, I'm just doing a random one. Let's see what is the answer I'm just getting here. The first article is displayed to me is the Wikipedia article, and the second article it just shows me the Britannia, which is the Wikipedia one, the older Wikipedia, and it goes for the some news channel. CNN goes for the CNN channel. But if you open your Google Chrome or if you do a Google operation, do you think you will also get the same result in your machine? The search result would be actually varied between you and me, because your search is kind of more different than my search. Do you agree with me? Can you give a search on your machine and try to see what is the result you're getting on your laptop?
Okay, I should do any search.
Yeah, you do a search on the country, the keyword called Africa.
Africa. Jobandrude. Africa. I can see. Well, the first one is just showing like a map,
Okay,
and
then
the other one Wikipedia, and then flags of different countries in Africa.
okay, that is your option you're
And
getting
then,
right.
huh?
Okay, so now do you agree what I have searched in my computer and what you are searching for the same keyword? We are both having a different results. Do you agree with me?
Yes, we are having different results. Yes. Why is that?
Yeah. So that is called something called relevance, or something would be more relevant. So the results being obtained based on your search experience. Based on your search experience, system have given preference that if this user is searching for Africa, then his intention or what she or he is expecting something is very different. Being I am from a different country, when I do a search, my result, what I displayed is something very different, right? So that's where we see something or relevance. Something might be more relevant for you, or the article would be more relevant for you. Some article would be more relevant for me. So do you see here, right? There's a small difference here. This is and all the place where Elasticsearch is extensively used. Are you clear?
Yes.
And
Okay. So with
another example.
Elasticsearch, search will reveal the same thing.
Yes, exactly. If you start using
Okay.
Elasticsearch to query a document, you can also build a similar search engine like this. That's the key idea here.
Okay. 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 That makes sense.
And if you have opened Wikipedia any chance before, if you just open here and if you have typed something on the search button, can you see the search bar here, right? On the top right.
Yes. On Wikipedia. Yes.
If I search something called maybe NA, can you see here, right? My search result has been auto completed. It can be a Narendra
Yes.
Modi, it can be a National Football League, it can be National Register of Historic and Nazi name are Germany. So with I'm typing partial word or a character, I'm able to extrapolate and then able to get the document name right. This is also a feature in Elasticsearch, which is they call as autocomplete. This feature name they call as
Okay.
autocomplete.
Yes.
Autocomplete is you type something partial. Now system is able to get enough information as you start typing. If I type NAB, now the document relevant to the NAB is actually displayed here. That's the this is again a feature of Elasticsearch. That's where the Wikipedia is using the system. Now you understand, right, where Wikipedia is used as a system and how it uses.
System. Okay. 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 So
Great,
now I get it.
perfect. Now let's understand the difference between a search engine and a database. What I meant by a search engine here is Elasticsearch is a search engine. The reason why I'm giving a name called search engine is like as we discussed few minutes back, we saw example for Africa, right? You are getting a
Yes.
different result and I'm getting a different result based out of some rank. These kind of system can be developed using Elasticsearch. That's why they call as a search engine here. If you go and type what a search engine in Google, the what result would be displayed is it is an information retrieval system. What that means is you can search something from the system and you get relevant information in some ranking order. That is the big whole idea here. Okay, that is where it comes in. That's why the Elasticsearch is called as a search engine. Now let's compare Elasticsearch or a search engine with the traditional database. That's where we are trying to understand the difference. The search engine, the main reason it is being designed is for the search. Like if the user want to search something, the key fundamental idea for a design system like Elasticsearch is for the searching operation. But in case of like a traditional database system, the main purpose of the design is for the persistence or for the general purpose. CRUID stands for create, read, update and delete. It stands for the create, read, update and delete. That's what it stands for. And the it's designed for the general purpose. The second point is search engine heavily operates on text data. Like if you want to understand what are the text data, then you might have to ask a question. What are the different data formats which I have in the available market or the different data format? One is the image, video, text file, and binary file. These are the general classification of the file format. Now, the search engine are designed to leverage or can improvise the performance of any text search document. Let's say you have any Facebook comment. We are not sure that what is the length of the comment, right? If I post some document, if I post some information in Facebook, my friends can type two-line comment or my friends can type one-line comment. Either of it is possible. In that case, what I'm trying to say that if the document contains like a lot of textual information, then Elasticsearch is the right candidate to pick and work. In case of database, it operates on rows and columns. That's the difference here. And the third important difference, what we have to understand here is, it search engine works on algorithm called TF-IDF, term frequency, inverse document frequency. Just for the names, you don't have to understand much on this part, algorithm part. We will understand later part. And the next part is It provide database works on algorithm called B tree. If you Google what is a B tree and what is TF and IDF algorithm, you will get a lot of information on those topics. That will give you like a better insight on that. The fourth part is Elasticsearch by default doesn't offer you the security and transaction like a SQL system. Anyone with having access to the computer can modify the system without any effort. But if you use any traditional system like SQL, user has to enter the username and password. Only when the username and password is correct, he or she would be given a complete access to the system. Till that point, user can't access system. Do you agree with me?
Okay, but the okay, yes,
And the last point to understand here is data is pre-processed before indexing. Here, when we say some data to be inserted into Elasticsearch, people you will use a name called indexing. The term indexing actually came from a normal colloquial term called index. If you open any book, you would have an index or a table of content, right? So that will contain the page number and the chapter description. Or if you open the end of your book, there will be a, like a bibliography, wherein which it will indicate that where each document is present. Let's say if you open and understand what is a word called computer, if the computer that system or that book speaks about computer, it will give you like listing or places where my word called computer is being listed. That is where the pre-processing is being done. In case of a traditional system, there is no such pre-processing technique. Data is stored as it is without any effort here. You are clear to this point?
yes, it is fine. So Elastic is a search engine, right, or a database?
It's a search engine.
It's a search engine. Okay.
And going forward, now let's understand what are the different terminologies and jargons used in Elasticsearch, or the concepts what we call in colloquial terms. The document, index, primary shard, node, cluster, and field. These are the words you will be keep on or often being repeated when you start understanding or start using the system. You will be hearing this word very often. Now let's understand what is a document in general. Have you heard about JSON document before, Victoria?
Yes, but I don't know
So
what it
if
is.
you, yeah, if you open and see any JSON document, let's say maybe let's have this document. It has the key and a value. It says that hey guy, and the number is something here, and the object, and you have something awesome is true and bogus equal to false. Now the JSON document is constructed using something called key value, collection of key value in a nested form. It creates a JSON document. The system also, the document in Elasticsearch also accepts the JSON document only. So whenever you want to insert something, it has to be a JSON document for sure. That's the whole idea here. Then the next point, what you see here is the index. The index is nothing but like a table in the database. Sorry, the database in the table in the database system. So let's see in real in the upcoming part, and you see something called primary shard. The primary shard is a piece where you store the actual data. Let's say if you have like 1,000 records, all the 1,000 record if it's stored in a shard called A, that becomes the primary copy, or that is the parent copy of that. If you have something called parent copy, then there will be have something called child copy or a mirror copy. So that mirror copy is something called as a replica. Now that replica will have the same copy as a parent copy, but in a different computer. In case one machine goes for off or there's some network kind of a damage or issue, other system can jump into the system, or other system can start using the backup server. That's where the sharding concept comes here. Are you clear?
Okay, you can continue.
Sure.
Sure.
And you have something called node. Node is nothing but if you install Elasticsearch in your laptop, then it becomes Elasticsearch node. Very simple as that. If anywhere you
It
install
becomes
Elastic,
Elastic.
Sorry?
If I start Elasticsearch on my computer, you said it becomes what?
It becomes node.
Node. Okay.
In case if you have a multiple laptop in your home or a multiple computer in the office, if you install Elasticsearch in each and every machine, then it becomes cluster, because now these group of computer together try to form a common name, the cluster name. Now that cluster becomes your operation. Now you understood what is a cluster, right?
Yes, I do. A collection of nodes.
Exactly, yes. Then you have something called field. That field contains a list of, like as we discussed earlier in the JSON document, this is called as a field, key and a value, or a field and a field name. That's why they call that something called node. Can you see this picture? The
Yes.
picture
Node
what
marked
I'm
down.
yeah. Let's say this is your laptop 1, node 1. Laptop 2 is something called node 2, and we have something called laptop 3 as a node 3. Now if you see here, my data has been split into three pieces. The primary data, P1 stands for primary shard. Now the primary shard is
Yes.
divided into three different chunks.
Why
P1,
is she meeting? Omo. Hello?
yes, hello,
You can, yeah, you can continue.
yeah. If you see here, my data is divided into three different pieces, which is something called P0, P1, and P2. Now all these divided pieces are left in three different nodes: laptop 1, laptop 2, and laptop 3. And you also have the replication thing, R0, R1, and R2. So now we have the primary copy here and replication copy. What if this node goes doesn't work? Now do you think whether this operation can collect all the data? Let's say if the node 3 doesn't work for a hard disk failure, or OS gets corrupted, can you able to retrieve all the information for the given piece? Is it possible?
What did you say?
I was explaining you that, let's say you have like 100 records or 200 records with you, okay?
Okay.
If you divide your data into three different pieces, now it becomes like 50, 50, 50, 50. Let's assume that you have like a document count of 150, 150. Now if you try to divide into three different pieces, P0, P1, and P2, each contains 50 documents. Are you with me till now?
Yes, I am.
If I have like data in three different node, I'm also having like three different copy of the same data. Now the P0 data will be replicated in the node R0, P1 will be replicated in R1, and P2 will be replicated in R2. Are you clear till this point?
Yes, I am.
Now, what I was saying earlier is, what if the machine 3 or laptop 3 does not work for some reason? From the given system, can you able to collect all the 150 records? Is it possible?
Yes, it's possible because it's been replicated.
Yes, that's the key idea here. The replication factor plays a vital role in providing the failover, and it provides you redundancy. Clear?